Hey everyone, and welcome back to the channel. If you're looking to level up your web development skills, you've come to the right place. Today, we're diving deep into a topic that's a game changer for building modern, high-performance web applications, mastering custom server logic in Next.js. Whether you're a seasoned developer or just starting your journey with React frameworks, this comprehensive guide will equip you with the knowledge you need to build faster, more scalable, and SEO-friendly applications. So why is server logic in Next.js so important? It's all about performance, scalability, and creating a seamless user experience. By offloading complex computations and data fetching to the server, you can deliver lightning-fast pages to your users, which is crucial in today's fast-paced digital world. Plus, it significantly improves your site's search engine optimization, or SEO, making it easier for people to find you online. Throughout this video, we'll break down the core concepts you need to master. Start with the fundamentals, demystifying server components, and how they work hand-in-hand with client components. Then we'll explore the power of server-side rendering, or SSR, and show you how to implement it effectively. We'll also get hands-on with API routes, which let you build a full-stack application within a single Next.js project. It's like having a Node.js server built right in. Ready to get started? Let's kick things off with the foundational building block of modern Next.js, server components. First things first, let's talk about server components. This is arguably one of the biggest paradigm shifts introduced in Next.js, starting with the app router. So, what are they? In simple terms, server components are React components that run exclusively on the server. They never ship any JavaScript to the client. This means your user's browser has less to download, parse, and execute, resulting in a significantly faster initial page load and a more responsive feel. Think about it this way. A lot of the UI on a web page doesn't need to be interactive. It's things like headers, footers, blog post content, or product descriptions are often just static content. Traditionally, even this static content would be rendered on the client, adding to the bundle size. With server components, all of that rendering work happens on the server. The browser receives plain HTML, which it can display almost instantly. This has a few massive advantages. First, performance. By keeping large dependencies and complex logic on the server, you drastically reduce your client-side JavaScript bundle. This is a huge win for users on slower networks or less powerful devices. Second, security. Since the code runs only on the server, you can safely access sensitive data and environment variables, like API keys or database credentials, without ever exposing them to the client. You can directly query your database from within your component. We'll touch more on that later. By default, in the Next.js app router, all components are server components. You have to explicitly opt in to create a client component by adding the use client directive at the top of the file. This makes you think intentionally about where your code should run. Good rule of thumb is to keep components as server components unless they absolutely need interactivity, like event listeners on click, on change. Use state and lifecycle effects, with hooks like useState and useFect. This server-first approach is key to building highly optimized Next.js applications. Now that we have a grasp on server components, let's move on to one of the most powerful features they enable: server-side rendering. SSR. Server-side rendering, or SSR, is a technique where the complete HTML for a page is generated on the server in response to a user's request. This pre-rendered HTML is then sent to the browser, which can immediately display the content to the user. While the browser is showing this static page, the necessary client-side JavaScript loads in the background to hydrate the page, making it fully interactive. This is a stark contrast to a pure client-side rendered CSR application, like a classic Create React app, where the server sends a nearly empty HTML file and a large JavaScript bundle. The browser then has to download, parse, and execute all that JavaScript just to render the initial view. This process can be slow, leaving the user staring at a blank screen or a loading spinner, which is bad for user experience and SEO. With SSR and Next.js, the user gets meaningful content almost instantly. This dramatically improves the perceived performance in key metrics like first contentful paint FCP. For search engine crawlers, it's a dream come true. Instead of seeing a blank page, they get a fully populated HTML document, making it easy for them to index your content and understand what your page is about. This directly translates to better search engine rankings. Implementing SSR in Next.js is remarkably straightforward, especially with the app router. By default, pages are statically rendered at build time. But if a page needs to fetch dynamic data for each request, you can easily opt in to dynamic rendering. For example, if you're fetching data using the Fetch API within a server component, you can simply add an option like cache, no store to your fetch call. This tells Next.js to re-render this page on the server for every single request, ensuring the data is always fresh. Imagine a user profile page. You want to fetch the latest user information every time someone visits? By using this dynamic rendering approach, Next.js will handle all the server-side logic for you. It fetches the data, renders the component with that data into HTML, and sends it down the wire. It's powerful, efficient, and a core part of building dynamic, server-driven applications with Next.js. Next, let's talk about building your own backend logic using API routes. What if you need to create your own API endpoints? Maybe to handle form submissions, process payments, or provide data to a mobile app. In the past, this often meant setting up and managing a completely separate backend server using something like express.js. This adds complexity, cost, and another moving part to your deployment process. This is where Next.js API routes come in. They allow you to create serverless API endpoints as a seamless part of your Next.js application. Inside the app API directory, any file you create becomes an API endpoint. For example, creating a file at app.api/hello/root.ts creates an endpoint accessible at API hello. Inside these root files, you can write standard Node.js code. You can export functions named after HTTP methods like get, post, put, and delete. These functions receive a request object and can return a response. It's incredibly intuitive. Let's say you want a simple get endpoint that returns a JSON message. You'd create your root.ts file, export an async function called get. Inside it, you'd return next response, JSON message, hello world, that's it. You now have a fully functional API endpoint. The real power here is that these routes run on the server in a serverless environment. This means they can securely connect to databases, interact with third-party services using secret keys, and perform any server-side logic you need without ever exposing that sensitive information to the client. You can build a complete full-stack application, front-end, and back-end all within one cohesive Next.js project. This simplifies your architecture, streamlines your development workflow, and makes deployment a breeze on platforms like Vercel. API routes are the perfect solution for when you need custom back-end functionality that goes beyond simply rendering pages. They are the glue that connects your interactive client-side components to your powerful server-side logic. Now let's connect all these pieces and talk about the most common server task, fetching data. One of the most significant benefits of using server-side logic in Next.js is the ability to fetch data directly and efficiently. With server components, you can co-locate your data fetching logic right alongside the component that uses it. This makes your code more organized and easier to understand. Forget about the old ways of fetching data on the client with useEffect and managing loading and error states with UCCET. Well, that's still necessary for client-side interactions. For the initial data load, server components simplify everything. Since they run on the server, they can communicate directly with your data sources. This could be a traditional database like PostgreSQL or MySQL, a headless CMS like Strapi or Contentful, or any external REST or GraphQL API. Because this communication happens on the server, you avoid the client-server waterfall problem. You don't have to wait for your component to render on the client and make an API request back to the server and then wait for the data to come back. Instead, the data is fetched on the server asterisk before asterisk any HTML is sent to the browser. The component is rendered with the data already in place. This results in a much faster and smoother user experience. Next.js extends the native Fetch API to give you fine-grained control over catching and revalidation. You can tell Next.js to cache the result of a fetch request forever, for a certain amount of time, or not at all. This allows you to fine-tune the performance of your application. For content that rarely changes, you can cache it aggressively. For data that needs to be real-time, you can opt out of catching. This powerful data fetching and catching strategy is built right into the framework, giving you incredible control over how your application behaves. So, from accessing a database directly to calling a third-party API, doing it inside a server component is the modern, efficient, and secure way to handle data in Next.js. Of course, theory is great, but the best way to truly master these concepts is by getting your hands dirty in building something. All the concepts we've discussed, server components, SSR, API routes, and data fetching are powerful tools, but they only become second nature through practice. My strongest recommendation is to start building projects. Don't just read about it. Do it. This hands-on experience is where the real learning happens. It's where you'll encounter challenges, debug issues, and have those moments that solidify your understanding. Start with something simple. How about a personal blog? This is a fantastic first project. You can use server components to render your blog posts, which is great for SEO. You can fetch your post content from markdown files or a headless CMS. Then, you could add an API route to handle a contact form submission. Feeling more ambitious? Try building a simple e-commerce site. You can have server-rendered product pages for fast loading and good SEO. You can use client components for interactive elements like an add to cart button. You could even build API routes to manage the shopping cart state or simulate a checkout process. Each project you build will present unique problems and force you to think critically about which Next.js feature is the right tool for the job. Should this page be statically generated or server-side rendered? Does this component need to be a client component, or can it stay on the server? When you start asking and answering these questions in the context of a real project, the concepts click into place. Don't be afraid to experiment, break things, and consult the documentation. Every bug you fix is a lesson learned. Finally, let's talk about how to keep your skills sharp in this ever-evolving ecosystem. The world of web development, and especially the JavaScript ecosystem, moves incredibly fast. Next.js is constantly evolving with new features, performance improvements, and best practices emerging with each new version. What was considered best practice a year ago might be outdated today. Therefore, staying updated is not just a good idea. It's essential for being an effective Next.js developer. Your number one resource should be the official Next.js documentation. The team at Vercel does an outstanding job of keeping it comprehensive, up-to-date, and full of excellent examples. Whenever a new version is released, make it a habit to read through the release notes and the updated documentation for any major changes. The Next.js blog is also a goldmine of information, often featuring deep dives into new features and the reasoning behind them. Beyond the official docs, immerse yourself in the community. Follow the Next.js team and prominent developers in the community on Twitter or X. Subscribe to YouTube channels like this one that cover Next.js and modern web development. Engage in discussions on platforms like GitHub discussions or Discord. Seeing how other developers are solving problems and using new features can provide invaluable insights. By continuously learning and adapting, you ensure that your skills remain relevant and that you're always building your applications using the most modern, efficient, and powerful techniques available. It's a commitment to lifelong learning, but it's what will set you apart as a top-tier developer. And that's a wrap on our deep dive into mastering custom server logic in Next.js. We've covered everything from the fundamentals of server components and the power of SSR to building your own backend with API routes and fetching data efficiently. Remember, the key is to embrace the server-first mindset that Next.js promotes. By keeping as much logic on the server as possible, you'll build faster, more secure, and more scalable applications. I hope you found this guide helpful and feel more confident in tackling server-side logic in your own projects. The best way to learn is by doing. So I encourage you to spin up a new Next.js app and start experimenting with these features today. If you enjoyed this video and learned something new, please give it a thumbs up. It really helps the channel. And if you want to see more content like this, don't forget to hit that subscribe button and turn on notifications so you won't miss our next video. Thanks so much for watching, and happy coding.